Hello, students. This is the first of probably a few of the online videos I'm going to try and shoot for the extended absences due to the coronavirus pandemic. All right, then. So we're going to start with a little bit of review. We talked about this in class on Friday. Not last Friday, of course, but 2 Fridays ago. Special right triangles. Now, I've uploaded this sheet of notes here into the note section of It's Learning. This extra practice worksheet here that's got the 2 theorems on the top and just 8 problems to practice. That is in the worksheets. You can do all of your work on a separate piece of paper or print this up and do it all on here. But when you upload work, and there'll be instructions coming soon about that, upload work for feedback, make sure you show me your work, not just the final answers, but your work. Circle your final answers, but mostly the work. All right. So I'm going to follow this procedure. Again, these have been uploaded to the notes section, and we're going to look at these few example problems. And I'm just going to work through the process and solve them. So first, we're going to write a proportion. It doesn't really matter which one of these, R or W, we use first. I think R is a better choice for our first side that we're going to solve for, and I'll explain at the end with hints and strategies. Well, I'll just tell you now, but I'll remind you again later. If you can solve for the short side, X, first, that's easier. All right, so our first ratio is from the problem. It's just a variable, so I'm solving for R first, and a number that I know. Doesn't really matter which goes on top or which goes on bottom, but what matters is when we use the theorem now that we correspond. So R is between 90 and 45 from the theorem, that's X. 8 is between 90 and 45 from the theorem, that is also X. Once you have your proportion written out, simplify, cross multiply, simplify. The first simplify means just cross the X's out. It always works out that way. You always have an X from the constants of proportionality. And now when we take the cross product, 1 times 8 is 8, R times 1 is R, and that is the answer for R. Now the reason it's easier when we solve for the shorter side is because now we can take our X value, which we actually had the whole time with this 8 right here, and it's always just going to be multiply by something to get the longer values. There's no dividing or anything. So R is already solved for. Let's go for W and 8. Okay, so W was the hypotenuse. The hypotenuse in the theorem is X root 2. And the 8, again, between 45 and 90, we use the angles to make sure we know what corresponds. It's just plain old X. The X's factor out. And now when I take the cross product, there's that multiplication I was just telling you about, because 1 times W is just W. So now all we have to do is multiply here, 8 times root 2, and that's it. Now I am going fairly quickly here. Make sure you pause the video, rewind, watch it over again if you need to. I'm going to pick up the pace a little bit more. Because the initial setups are pretty much always the same. Where I'm going to focus on more now is the simplify here at the end, which has a couple little facets to it, I guess. We'll see in this example here. We're going to encounter some of those. So R and 4. Okay, a side I know, a side I'm looking for. Okay, from the theorem, the R that I put in the numerator, got to right angles in this problem. That was silly of me. It's supposed to be a 45, 45, 90. So R is the side between 45 and 90 from the theorem, that's x. 4 is the hypotenuse, and from the theorem, that is x root 2. Okay, the x's will always factor out, 1 left over. And when we take the cross product now, we have r times root 2 equals 4 times 1, which is 4. And now when we get the r by itself by dividing both sides by root 2, here's where we have some more simplifying to do. All right, so the simplified procedure, we can factor out whole numbers. You can factor a whole number with a whole number, but not a whole number with a radical. Rationalized denominator, that's just, we're not allowed to have a square root in the denominator. So if you have a square root in the denominator, like I have here, we're going to multiply the numerator and the denominator by the radical denominator over itself. Because whatever a radical times itself is, then the square and the square root cancel each other out, and you just get that number. And then the radical is in the numerator. It's okay to have a radical in the numerator. So I can't divide a 2 out here because it's the whole number 4 and the radical number 2. So I'm going to multiply by root 2 over root 2, and that gives me 4 times root 2, 4 root 2, and root 2 times root 2 is 2. But now I can factor the whole number 2 out of that 4 and the 2. So r equals 2 root 2. Now, oops, move my camera there. Solving for w, w is actually the same side as r. So r over w, which is really 2 root 2 over w, is x over x from the theorem because they're the same side. So when I cross multiply here, I'm just going to get w equals 2 root 2. There's some shortcuts that you're going to see here. In a 45, 45, 90, two of the sides are the same. So once you know one of the legs, the other is the exact same. All right, setting this one up here, I'll solve for w first, I guess. It doesn't really matter here. I know the short side. So this one is going to be, I'll show the theorem here. There we go. All right, so the 4 is the side between 60 and 90. That's going to correspond to x in the numerator. The w is the hypotenuse between 30 and 60. That's going to correspond to 2x. Per usual, x's factor out. And now when we take the cross product, 2 times 4 is 8. W times the 1 is left over. W times that 1 is w. We have that. Okay. R and 4. R is the side that is between 30 and 90, so that's going to match up with x root 3. And then 4 is just the x side again. Per usual, the x's factor out. 4 times root 3 is r times 1. And done. All right, getting close to 10 minutes. I want to keep this video as close to 10 minutes as possible. It's going to be a little bit over, but hopefully not so much. All right, next, okay. Here I have two sides, and looking at the theorem here, x is the side that's between 60 and 90. Because I have the option, it's always best to solve for the x first if you can. So my first ratio is from the problem, a variable and a known number. Okay, r is between 60 and 90. That matches up with x. 12 is the hypotenuse, matches up with 2x. And as always, The x factors out. 2 times r equals 12 times 1. And now we'll just divide by 2. R equals 6. And now that we know r is 6, that's actually going to be an easier way to get to w versus using the 12 again. We should just use the short side 6. So 6 over w equals x over x root 3. Again, corresponding. W is between 30 and 90, so that's the x root 3 side. X's cancel. W times 1 is w. 6 times root 3 is 6 root 3. So it's a little bit easier if we solve for the short side first. All right. 2 more, and then we'll call this a video. All right. So again, I have options here. I have either the short side r, which is the side between 60 and 90, so that corresponds to x. And then w is the hypotenuse, and that corresponds to 2x. So I could solve for w here first if I wanted to, but solving for r first is easier. So known side and a variable corresponding from the theorem between 60 and 90 is the x. Between 30 and 90, matching up with the 12, is the x root 3. Between the 30 and the 90. X's factor, 1 left over. R times root 3 equals 12 times 1. And now, to get r by itself, we'll divide both sides by root 3. And now we have a little bit more simplifying to do. Because I got a radical in the denominator. So we'll multiply the fraction by the radical denominator over itself. 12 times root 3 in the numerator. Root 3 times root 3 is the whole number 3 in the denominator. And then we can actually factor the whole number 3 out of 3 and 12. R is 4 root 3. And now that we have the short side, we can get w even easier. 4 root 3 over w equals x over 2x. Again, the hypotenuse is the 2x side. And now w is just multiplied by 1, so that's plain old w. And all I have to do here is multiply 2 times 4 root 3. And 4 root 3 is 4 times root 3. So that is 8 root 3. Last example is a compound example here. We got 3 different things to solve for. 4 different things to solve for. First, the r value. They're both the legs of the 45, 45, 90, so it's a 1-to-1 relationship. When we cross multiply here, we just get r equals 4. Just put that right in the problem there. Our next guy to solve for is w. 4 to w equals x over x root 2. The x's factor. If you're noticing the x's always factor out, you might even take a shortcut and not even multiply, not even put the x in there in the first place. And just leave it like 1 over root 2. All right, so there's w, and now w is the side on the 30, 60, 90 between the 60 and the 90. So now when I look at, put in my picture here, mark up the picture, always a good idea. Now when I solve for q over 4 root 2 equals, q is the hypotenuse between 30 and 60, so that's going to match up with 2x. And then between 60 and 90, the 4 root 2 matches up with x. Again, the x's factor out. Take the cross product, q times 1, that's q. And then 2 times 4 root 2 is 4 times 2 is 8 root 2. 8 root 2. And the last one for this lovely video, Z. Z is between 30 and 90. And the theorem between 30 and 90 is x root 3. And again, 4 root 2 is the short side, that's just plain old x. X's factor out. Z times 1 is z. And now 4 times root 2 times root 3. This is another weird little simplification. You can factor whole number with whole number, and just the same, you can multiply whole number with whole number, as we did here a moment ago when I multiplied 2 times 4 root 2. That's just 8 root 2. And just the same, you can multiply radicals. So I can't multiply 4 times these guys, but I can multiply these two with each other. So root 2 times root 3 is root 6. That's that. So it is the problems there. I'm going to leave this on screen for a second. You can pause the video if you need to look in on any of these, zoom in, rewind the video. This is the worksheet associated with this mini lesson. There will be 3 other videos and work problems for this week. This is for the week of, what is this the week of? Let's see, it's Sunday. So the 23rd, March 23rd through, I guess, the 28th, right? Yeah, 27th. All right, so for the week of the 23rd through the 27th, there'll be 4 video lessons and 4 worksheets. All of these will be due on the following Monday, which is the 30th of March, by 9 o'clock in the morning. You can send them pictures of them to the email, or I may have some other online platform set up soon. Google Doc. You can certainly share Google Doc with me. All right, I'm going to call this a video because I got to shoot a bunch of others